Quantum Computing 2025, Hack-Proof Internet, A Drive-In Science, and the Future of Humanity Introduction. We are entering an era where computers no longer just calculate, they follow the fundamental laws of nature to think, predict, and discover. The United Nations declared 2025 as the International Year of Quantum Science and Technology, marking a historic turning point in human innovation. In this video, we will explore what quantum computing really is, why 2025 is such a landmark year, how hack-proof internet is becoming possible, and how A Drive-In Science and gene therapy are transforming medicine and technology. Chapter 1. What is quantum computing? Traditional computers process information using bits, which exist as either 0 or 1. Quantum computers use qubits, which can exist as 0 and 1 at the same time, a phenomenon known as superposition. Another key concept is quantum entanglement, where two qubits become so deeply connected that changing the state of one instantly affects the other, regardless of distance. Because of these properties, quantum computers can solve extremely complex problems that are practically impossible for even the most powerful classical supercomputers. Chapter 2. A brief history of quantum computing. The idea of quantum computing emerged in the 1980s when Nobel Prize-winning physicist Richard Feynman suggested that nature itself should be simulated using quantum systems. For decades, quantum computing remained largely theoretical. In the early 2000s, companies like IBM, Google, and leading universities began building experimental qubits. In 2019, Google announced it had achieved quantum supremacy, demonstrating that a quantum computer could outperform classical computers for a specific task. All of this research set the stage for the breakthroughs that became visible in 2025. Chapter 3. 2025, the International Year of Quantum Science and Technology. When the United Nations declared 2025 as the International Year of Quantum Science and Technology, it sent a clear message to the world. Quantum technology is no longer a distant future, it is a present-day reality. The goal of this initiative was to inspire young scientists and researchers, strengthen collaboration between industry and academia, enable developing countries to participate in quantum research. As a result, quantum science moved from specialized laboratories into global focus. Chapter 4. Toward a hack-proof internet. Quantum networks. In 2025, major progress was made by Argonne National Laboratory and Yale University in developing a specialized operating system for quantum networks. At the heart of this innovation is quantum key distribution (QKD). According to the laws of quantum physics, any attempt to intercept or spy on transmitted data immediately alters the quantum state, revealing the intrusion. This means the future internet could be virtually hack-proof. Banking systems, military communications, government secrets, and personal medical data would all gain an unprecedented level of security. Chapter 5. A Drive-In Science, a new research paradigm. One of the defining characteristics of U.S. research in 2025 was the rise of A Drive-In Science. Artificial intelligence identifies promising solutions, while quantum computers perform massive calculations at extraordinary speed. Together they enable discovery of new materials, design of high-performance batteries, more accurate climate change models. This collaboration dramatically accelerates scientific discovery. Chapter 6. Gene therapy and the medical revolution. The impact of quantum computing and AI extends beyond technology into medicine. In 2025, gene therapy reached a new level of precision and effectiveness. Personalized treatments for cancer, rare genetic disorders, and neurological diseases became increasingly achievable. Quantum simulations allow scientists to test drug molecules before physical trials, reducing both time and cost. These advances bring humanity closer to curing diseases once considered untreatable. Chapter 7. Opportunities, challenges, and the road ahead. Despite enormous potential, challenges remain. Maintaining qubit stability, reducing system costs, and developing skilled professionals are major hurdles. However, the progress made in 2025 proves that these challenges can be overcome through sustained research, collaboration, and investment. Conclusion. Quantum computing teaches us a powerful lesson. When we understand the laws of nature, we can break technological limits. The year 2025 is not just another date on the calendar, it represents a turning point. Hack-proof internet, A Drive-In Science, and breakthroughs in gene therapy are redefining the future of humanity. To understand tomorrow's world, we must understand quantum science today. Call to action. If you found this video insightful, please like, share, and subscribe for more science and technology content.